Hey guys, welcome to another bang of a math. So here I'll be simplifying these things, you know. These sets, guys. These sets. Um so guys, that's how this thing it goes, man. All this question now, I won't do this one, all this one. I will leave it to you, those one. And if you want to check your answer, are you correct or are you wrong? You will use a calculator there by using a cheating method. Do you see? Meaning the first answer is supposed to get this thing there. Yeah, you're supposed to get that. Then for the second answer, you're supposed to get this thing there. From my previous video there, I showed you how to simplify these things. You should simplify these things without using a calculator. Just apply what you know there. Do you understand? But what I want you to show you now is this one there. Do you see? As I told you that I'll start from 1.7 until that 1.15. All the other one, I leave it for you, those one. Do you see? So let's just start with this question, guys. Now for this question, guys, now you should be careful then. Now we are no longer talking about perfect square there. Perfect square. We're talking about what? Perfect cube there. Because there we got a cube there. Do you see? Perfect cube. Man. Then for you to get what a perfect cube, guys, this is what you can do there. Now you should try to introduce a perfect cube there by saying 16 divided by 2, meaning that 8 there, it's a perfect cube there. Meaning now you can take these two things there, write them like this, they say 8 multiplied by 2, say 3 then just like this. You see this thing? Yeah, because when you multiply them they still give you 16, but there you just introduce a cube root there. There you introduce a perfect cube there, a perfect cube which is that 8, then you can just write it here as which is 8 multiplied by 3, just like that. Do you see this thing? Yeah, what you just apply now, you have applied that law there. You have break down the cube root there to become like this there. That's how you break that cube root there. But now because when you take a cube root of 8, shift this, cube root of 8 there, it's 2. Meaning this thing is supposed to give you 2, and this one you can't take the cube root of this one there. Do you see? Yeah, then now you can leave your answer just like this there. But now here to confirm your answer, is it correct or wrong? Let's try to press all of that thing there, which is that thing there, it's 16, which is that, do you see? I just got some decimal numbers there. Let me just press there, it's decimal numbers, 98421. From here, that is the number that I get them. Do you see? So now what I will do, I will also press this one, try to check, will I get the same number as that one? This is how I will do it, 2 cube 2. Do you see? Still I get the same number there, which is this thing there, it's still one and the same. Do you see? Yeah, so sometimes this is the negative impact of using a calculator. If you just press all of that thing, you just come with that answer, they will recognize you that you have cheated them. Do you understand? So it's better for you to apply the rules until you leave your answer in a simplest set there. This thing is a simplest set there. Then let's try to introduce the perfect cube of this number there. So for you to introduce a perfect cube of that number, you should introduce one of these numbers here. So this is how I'll do it. 96 divide, it's 96 there, I'll say 96 divided by 2 divide, okay, 96 divided by 2. This number, it's not there, meaning that it's not a perfect cube. 3, there is no any perfect cube here. Let's try this. There is no any perfect cube. 5, there is no any perfect cube. This one, there is no any perfect cube there. What about 7? There is no any perfect cube. What about 8? if you can take note, that 8, guys, it's a perfect cube there. Do you see? Meaning now I will just say perfect cube multiplied by 12. And this thing there, I can also write it like 3, 8 multiplied by 3, 12 there. Cube root of that and that there. I break down the cube root there. And now the cube root of this thing there, I know that it's 2, 3, which is 12. Then you leave your answer, guys, like this there. Don't try to be a genius, leave your answer in decimal. The moment you leave your answer in decimal, you show them that you have used the calculator there. You see, leave your answer like that there. And if you want to confirm your answer, you'll press everything there, just like this, which is 96. There it will give you some decimals there, meaning this is what you will get there. 88567. Even when I press this thing, I should get the same decimal there, which is 2, shift this, and 12 there. Do you see? Yeah, which I still get the same decimal. These two things are the same, that they got the same answer, meaning my answer is correct. What about for this one? From that previous video, I show you guys how to deal with this kind of question there. You can't leave your answer just like this here. Here we got invisible 2, say inside divided by 2. Do you see? Yeah, it's correct, but you can't leave your answer in a decimal exponent. We don't have a decimal exponent, guys. You can't leave your answer like this there. This one, it will lead you to become wrong. Let me show you a good approach. What you should do there, you should try to introduce even number. This is how you do. Say 2 plus 1. Do you see? Yeah. And now you break the exponent according to the laws of exponents. I show you how do you break the exponents. You break that exponent like 2 multiplied by x1. Do you see? And now you can apply the rules for sets there. You can break this thing like 2 multiplied by this x. Do you see? And now when I take the square root of this thing, I will have that exponent. It will give me x and x there. That one is my final answer there. Do you see, guys, this thing? Yeah. So please, guys, avoid to leave your answer in that form. Yeah. Just leave your answer in the simplest square there, or simplest set. That's a simplest set there. Then for this one now, here we're dealing with a square root, meaning that I should try to introduce a perfect square there. Here I was dealing with a cube root. I was introducing a perfect cube there. But here I'm introducing a perfect square. How do you introduce the perfect square? You just say 20 divided by 2, meaning that it's 20, here it will be 10. That 10, guys, it's a perfect cube, first of all. Oh, that 10 there, guys, it's not even a perfect square there. Do you see? Let's try to 3. There's no any perfect square. 4. That 4, guys, it's a perfect square. Do you see? Meaning that I can take 4 here. I can say 4 multiplied by 5. Then for that one there, I can just break them like this. It's 4. And here it's B3. Do you see this thing? And now this one, guys, I can introduce an even number there. A number that can be divided by 2. This one is already even number there. It can be divided by that invisible 2. So here, this is what I will do, which is here it's 5. Then for this one there, I can just take the square root of this thing. I will have that thing. Then for this one, it will be 2 plus 1. Do you see? Yeah. Then for this one, it will give me 2 and 5. And that 2 there will be here. Multiplied by, for this one there, it will be 2, 1 there. Do you see, guys, this thing? Yeah, because this thing there, don't get confused, guys. Here I just skip that step of saying it's 2 multiplied by b. I just skip that step there. This step I skip it, I just come with this one there, whereby I just break this thing, become like that there. So this thing there is the same as b, because I will have that 2 multiply, here it's b. So I'll have that 2 and here it's b, which is here it's a2 and 5, which is 2 there. So now what I should do now, I can multiply these together, those one. All these one I can multiply them together. All those one I can multiply them together. Even this one I can multiply them together. Meaning now my final answer will be AB like that there, which is 5B square. Do you see, guys, this thing? Which is squared then, just like that then. Yeah. So there is no A inside. What is the reason? Because here I was taking a what? I half that A there. I half it, then it become like 2 because it's already an even number. But for this one, I was supposed to introduce an even number, then I add it by 1, then I break the exponent, then I separate the what? The square root. Then now that's why now I will take that, and the other B there will be left on a what? On a square root there. Yeah. Then what about for this one then? This. Then for this one, still you apply the same method